Good day. So today we are talking about quadratic equations, also parabolas, same thing, in intercept form. Now what intercept means is where it crosses usually an axis. In this case it's the x-axis. But what's important here is the form is y equals a times x minus p times x minus q, where p and q are the x-intercepts, where it crosses the x-axis. To find the x value of this vertex, so the first thing we're going to find is the vertex here. To find the x value, you have to find p plus q and divide it by 2. And then to find the y value of the vertex, you're going to substitute the value we get here back into the original equation and solve for y. That will give you the y value of the vertex. So we're plugging it back in and solving for y. All right, here's our first example. I put the original form up above. Y equals x plus 5 times x minus 7. Now, here's the real trick to all this. See how it says x minus p, but this says x plus 5? Another way to write that, let me just move this stuff down a little bit so I have a little more room. Another way to write this is x minus negative 5. I think you'd agree that subtracting a negative is the same as adding a positive. So when we look at it that way, this is the p value, negative 5. Minus what? Minus positive 7. So q is positive 7. So this is what is being subtracted. Now that's one way to look at it. The other way that people will look at this is they'll say, since it's minus p, p is the opposite of what it looks like here. This looks like a positive 5, p is the opposite of that, negative 5. Q is the opposite of negative 7 or positive 7. That's the other way you could approach this. So now if I try to find the value of x that works here, now I'm going to move these back up so we have that room. X is equal to p, negative 5, plus q, positive 7, over 2. Negative 5 plus 7 is positive 2 over 2, which equals 1. So to find the x value of the vertex, we just found that that equals 1. So this is our vertex. The y value of the vertex, we're going to plug back in. Y equals x plus 5, I leave space there, x minus 7. And I'm plugging that 1 from the x value of the vertex back in so that I can find the y value. Y equals 1 plus 5 is 6. 1 minus 7 is negative 6. Answer, negative 36. This form tends to be a little bit harder to graph on an XY grid just because it's hard to come up with nice examples that graph easily. Other points that you can find here, we could find several others. We could go up by 1 and down by 1. So like we could use values like 2 and 3 and 0 and negative 1. But the other values that we also want to make sure we include, let me just move all this down just a hair so that we have enough room. Ooh, that's not what I wanted. All right, so we have enough room for all of this. Other values that we would want to consider is when x is positive 7, y is going to be 0 because that's the x-intercept. 0 for y, x is 7. And we can also expect And this, let me just extend this down once I get it to register. There we go. We also know that when x is negative 5, y is 0. Now think about that. Let me just give myself a little room to write here. When I think about that, y equals something for x plus 5 times something for x minus 7. If I fill in negative 5 here, it doesn't matter that what this whole thing comes out to, because negative 5 plus 5 is 0, and 0 times anything is 0. And then we could also use the same approach when I plug in 7. This comes out to 0, so no matter what this is, it doesn't matter. Times 0 is still 0. That's why those y-intercepts work so well. X-intercept, excuse me, not y-intercept. All right, so let's find a couple other points just to do it. Y equals something x plus 5 times something x minus 7. And we'll try 2. Remember, equidistant from the vertex gives you the same y values. So we're going to plug these in. 2 plus 5 is 7. 2 minus 7 is negative 5. The result is negative 35. See how close that is to negative 36? Now if I do that again, but with 0 this time, 0, 0. 0 plus 5 is 5. 0 minus 7 is negative 7. Negative 35 again. Let's try the other two numbers that we have here. Let's see, negative 1 and positive 3. These aren't the only numbers we could use, but it's nice to use at least 3 or 5 numbers total in a row here when possible. So let's do 3. 3 plus 5 is 8. 3 minus 7 is negative 4. The result would be negative 32. And of course, we should get the same when we plug in negative 1. Let's see. Make sure we get the same. Negative 1, negative 1. Negative 1 times 5 is 4. Negative 1 and negative 7 is negative 8. Look at that. Negative 32. You can graph a parabola with just the vertex and those intercepts in certain cases, but having more points makes it a little easier to make that sketch of the graph. All right, let's move on to our next example. Whoa, too far. There we go. See if you can come up with the x value of the vertex, and then we'll do it together. So pause the video, do the x value of the vertex, and then we'll do that part together. All right, so P is going to be opposite sign negative 6. Q is going to be opposite sign negative 4. So the x value of the vertex is negative 6 plus negative 4 over 2. That's going to be negative 10 over 2 or negative 5. So the x value of my vertex is negative 5. If I plug that back in, I'll find the y value of my vertex. When I plug in negative 5, negative 2 times negative 5 plus 6 is 1. Negative 5 plus 4 is negative 1. And when I multiply these together, negative 2, positive 1, and negative 1, that's going to make a positive 2. There's my vertex. Now let's try this again with other values. We already know P and Q are our intercepts. So we could say -6, I want to do -4 there. -4, actually, let's bring that down here. Come on, board is being slow today. And -6, those are going to both be 0. We knew that because there are P and Q. P 0 and Q 0, or vice versa. And those are definitely in there. You can try other points like -3 and -7. -3. -3 plus 6 is 3. -3 plus 4 is 1. And when I multiply these together, I get -6. We should get the same thing when we plug in -7. So if I put down the marker. All right, -7. -2. -7 plus 6 is -1. -7 plus 4 is -3. I multiply -6. Negative times a negative times a negative. Positive, negative. -6. And that would be the points here. Last but not least, try to find both the x and the y values for the vertex here, and then try to find a couple other points. I'll let you pause the video and do that, and then when you come back, we will do it out together. P is going to have to be 8, and Q is 4. So in that case, we know that 8, 0, and 4, 0 will be 2 of our points. X is going to be 8 plus 4 over 2, 12 over 2, or 6. In fact, I'm going to move that up over here. The y value is 5 times x minus 8, x minus 4. And we're going to fill in 6. 6 minus 8 is -2. 6 minus 4 is +2. And when I multiply these together, I get -20. So I've got my x and my y values. X is 6, y is -20. That's quite a ways down. Usually you go past, say, 10 or 15 in any one direction, and that's a long way. So -20 is quite a ways down. Let's do, how about 7 and 5? We'll throw those in there and see how they work out. 7. 7 minus 8 is -1. 7 minus 4 is 3. And when I multiply, I get -15. 5 minus 8, so I've got 5 on the outside. 5 minus 8 is -3. 5 minus 4 is 1. -15 again when I multiply. There you have it, folks. That's the entire lesson on finding vertex. Of course, in this case, this is our vertex. This is our x-intercept. And another x-intercept. And that's how you could graph it. Just plot those points and graph it, and there you have it. That's all there is to it for today. Thank you very much for joining me.